Hello. So now in this tutorial, we are going to learn how do you simulate your design. So in the last tutorial, I showed you that how do you create your design modules into your design sources. So in this tutorial, we are going to explore this tab, which is the simulation sources. So this is where you put all your test benches that you have written in the code, or you want to write your code, write your test bench for your code. So let's create our own test bench for this my end gate, and we'll see okay, how can we simulate this. So select the simulation in sources and click add source, and it will by default select add or create simulation sources. Click next, and here you will add a test bench. You can add a test bench file written in Verilog already here, or you can create your own. So let's call it test bench. And okay, so then click finish, and it will ask you for the inputs and outputs. So as you know, the test bench as a module doesn't have the inputs and outputs. So we'll click cancel and click yes. So if you do that, then you'll see okay, there is a module, there's a file created into the simulation branch, simulation sources, which will be test bench underscore end that we just created. So here you will define your test bench, and you create your test cases into this. So one thing very important here is that you want uh, the name of the module should be the same as that you defined. Okay, so test bench underscore end should be the same as test bench underscore end. So this is the module here. And second thing you want to do is define the simulation timestamps. So we'll come to that point in a moment. Okay, so first is that you first want to, so we want to test this module, which is the end gate module. So it means we need two registers. So we are going to define an array of registers, which is, let's call it my switch, right? And we need a wire so that we can see the change in the output whenever the input is changing, right? So that's why we will be manipulating the registers, and we'll be observing the output on the wire, which is LED. So let's call it my LED. And so now we will instantiate our module. So let's call it my end, and we'll name it module under test, right? So let's now we'll keep the inputs and outputs in the same sequence that we have. So let's so the first input is the first order the inputs. So we'll say that there's a my switch, and so it's input one, my switch, so 0, and then you have my LED. Okay, so we connected our test bench inputs and outputs with our module. So now we have to create the cases. So give what cases that we want to test your module or our module. So let's create an initial block, initial and begin. Each begin has an end. So let's now uh, create the test cases. So the first case that we want to see is given what will happen when we apply 0, 0 to it. So my is W, it will be, it's a 2-bit assignment that we want to assign. So 2 binary 0, 0. Right, so this is the first we want to test, and we want to make sure that when this test is happening, we want to define the simulation time. That this is going to happen at 100 simulation time unit. So you may want to define what's the simulation time unit. So you can do this by this instruction. You can copy and paste simply this instruction, which is let's copy this again. Control C. I don't. So let's make it time scale 1 nanosecond / space simulation time. Okay, so this is this one. Okay, so yeah, so this is how you define your time scale here. That times so the one simulation time unit is 1 nanosecond. This is what say it means. This is saying there are 100 at the 100th nanosecond. your my switch will become, both inputs will become 0 0. So now you will apply 0 1 1 0 and 1 1. So you have created your test bench now. So let's run the test bench and run the simulation and see how does the output appears in this case. So let's run behavioral simulation. So what we expect here that this will run our test bench file and will apply all these signals that we have applied, which is 0 0 0 1 1 0 and 1 1, and we expect that the output should be the output of a simple AND gate, because essentially we have only AND gate implemented. Okay, so we have the simulation output ready. So let's see. First of all, you want to see the zoom fit, right? You may want to break down this array into the individual bits, and let's see what we are seeing. So at the 100th nanosecond, your output starts changing. It becomes 0 0, and the output is equal to 0. 0 1 output is equal to 0, and 1 0 output is equal to 0, and 1 1 and output is equal to 1. And the simulation continues because we didn't define, we didn't change this register values. So it basically verifies our operation that we want to, our circuit is working fine. Okay, so this is how you verify your designs by test benches in Vivado. In next video, we are going to learn how do you actually program this onto your board.